So here's a problem. Regular six-sided die is going to be rolled 60 times. We're going to take the square of each outcome and record it. So 1 squared is 1, 2 squared is 4, all the way up to, if we get a 6 on the die and square it, we get a 36. Find the probability that the mean result of the 60 rolls will be at most 14. Well, of interest to us is what would the mean and the standard deviation of these values be? Well, we get that mean and that standard deviation for this discrete skewed right distribution that only has those 6 outcomes right there. So how in the world are we supposed to find that probability that the mean of 60 rolls would be at most 14? Well, that's what we just got done studying. So we got the mean and the standard deviation. So we know, even if the distribution wouldn't be normal, that this is how we find the mean of all sample means taken from samples of 60 and the standard deviation of all those sample means. So if we go back to our probability distribution, that purple looking normal distribution is where the sample means should lie from samples of size 60. We should on average get about 10 of each of those numbers in our sample. When we add those up and divide by 60, we get a mean average really close to 15, just above it, with a little bit of standard deviation, that 1.57. So that normal distribution is the approximate distribution of how sample means should be. And now we go down here and we'll say, well, let's find the probability that the sample mean we would get is less than or equal to 14. Show the work like we do, and we find the probability to be 0.2296. So now we're starting to realize just how important the study of a normal distribution is in the world of statistics. That original population is not at all normal, it's not continuous, and it's not bell-shaped, but take a big enough sample size, a size of 30 or more, and the sample means are going to be approximately normally distributed, we can get z-scores and use those to find probabilities.